Welcome to Wednesday of week 3 in the recording. We did one example problem about measurement unit scoots. This was number 4 of the turn-in problems for shape-shifting measurement. We were starting in millimeters, green, moving to centimeters, red. That was 1 scoot to the left. So then after I figured that out, I can look at the 0.27, say 1 scoot to the left, and I get 0.027. Okay, before we move on with math, I want to talk about what we should do on Monday, because this is the strange spring 2020 distance learning term and the routines are messed up. So what it normally asks us to do when you're looking at the achievements is to have a midterm. That you can get 1 star here. You don't need all 4 stars in this taking a test section. But you can get one of them done by taking a midterm and doing reasonably well at it. And if you had that checked off, then you wouldn't need to check off something else, like maybe getting a very good score on the final. It's also true that you can get a time management star for writing out a study schedule and plan after a midterm, because that's really what midterms are for, is to let you know how you're doing, if you have everything mastered or not at that point. No one else in the world cares how much math you know at week 3 or 4 of a term. So it would be good to do something like that, to say that I've checked in with myself, I've taken some sort of midterm, I know if I'm on top of things or if I'm falling behind, and so on. What that looks like this term, I'm not quite sure. So let me show you first what the midterm is, and then we can talk about how this works. So if you go to the math playgrounds, then down at the bottom, past the explorations, past the reflections, past the big issues without right answers, you get practice tests. And so there is one for shape-shifting. And if I look at it, then it looks like this. We have, why did they all change to italics starting there? Oh, because I made a mistake. Okay, anyway, I can fix that later. So we have 28 problems, all of which look like things you've done before. And if it takes you maybe 4 minutes to do a problem, then this could be a long time. So we certainly don't want to just all be looking at each other in Zoom doing this during a normal class time. An obvious thing to do would be to try and make this something you do on your own at home and then turn it in. We can talk about if that's good to do and what that might actually look like. Taking a test that has 28 problems all at once is kind of the wrong way to study. So if you want to see how you're doing, then that might be useful. But when we're reading about the tests up here, then this is worth going over. I was even thinking of recording a video about teaching you a few Tai Chi steps, but I didn't have a good time this week. So if I was to teach you some Tai Chi, then I wouldn't say, let's do all of the steps of the Yang short form right away. I would say, here's like the first thing we do. We put our feet this way and so on. And we would do that a few times and feel our balance, and feel how our leg muscles are engaged, and so on. Then we'd say, here's the second step. We do this thing with our shoulders. And we would practice just that a little bit. And then we'd back up and say, we'll do the first thing and the second thing together. And we'd repeat them both a few times. Then I might throw in the third step, where you sort of twist your torso a little bit. And then we would practice just the third step and then maybe build it in with the first 2 steps and so on. And after 3 steps, maybe we're just done with those for a while. We're going to set them behind us for a moment. And we'll say, let's look at just the 4th step, and then eventually build on the 5th and the 6th. And once we do 4, 5, 6 smoothly, then we can go back, pick up the 1, 2, and 3 we had left behind and see if we can do 1 through 6 and so on. Does that make sense? You don't just say, let's try 6 things, because you can't learn 6 things at once. So if you are taking a practice test, it's exactly the same, even though it's not Tai Chi. Even if the test was just 10 problems, like on the screen right now, If you were to try and practice 10 things at once, that wouldn't be helpful because you can't learn 10 things at once. That's not how our brains work. So you would practice just the first problem until you got that one done. Then you could say, let's do the first 2 problems until we're pretty smooth at those. Then you might say, let's do the first 3 problems until they go smoothly. And then you might set those behind you and say, okay, let's work on number 4, and then we can work on 4 and 5, and then we can work on 4, 5, and 6. And once those are smooth, then maybe I'll go back and try all 6 at once, or so on. Some routine like that, where you're slowly adding things, and you're not focusing on more than 2 or 3 at a time, unless you're ready for some overall review. So when you're studying for an assessment, whether it's a midterm or a final or whatever, then that's what you do. You don't just sit down and do the whole thing, because that's probably a waste of time. So I want to encourage that good habit. I don't want to say, this is Wednesday, we have a weekend coming up. I want everyone to sit down and get frustrated looking at a page with 28 problems, because that's not going to help anybody. What we would normally do during a normal math class, when you're all in the same room, is split the time into 2 40-minute segments. It would be an 80-minute class. And we'd spend the first half pretending it's a traditional test and you work by yourself. And then the second half, we break into groups and you compare what you've done with everyone that's sitting near you. And you talk about why your answers don't match up, and so you all agree on one answer, and you all make it nicely in your notes, because you're not going to be able to study for the final with your neighbor's notes. And then when you're done, you write a little study plan, and before you leave the room, you've done all of these steps. That you will have a version of the test that has good answers with steps for all of the problems, some of which you worked on hard by yourself, others which you did with a group, and then you have that to study with later on in the term when the final comes. But Zoom is not good for this. It's very hard to work with your neighbor on a few problems. I could make breakout rooms and put people into small groups of 3 or 4 or 5, but even then, you don't have the fun pen and tablet thing to write on like I do. It's hard for you to write on the screen. It would be very bulky to write on paper and hold it up to your webcams, or to take photographs with your phone and try and somehow email them to each other or something. It's just hard to collaborate with written work using Zoom. That's not what it's designed for very well. And so this traditional midterm schedule of do some things by yourself and then compare answers with people isn't going to work well this term, even though it's kind of the right way to do things if we could. So that's my dilemma. I'm going to stop the screen share for now, and let's just talk about what we should do. When do you want to try and do a take-home test? Knowing that it's one of many ways to get a testing star checked off. Do you want to try and do some group work outside of the study sessions, because group work is helpful? Things like that. Tell me your ideas.
Did you say you didn't want us to try it over the weekend?
We could. I mean, since it is not something that people need to do, nor do they need to do at best their first attempt, then we could always say, you know, if you want to try it over the weekend, go ahead. Can't hurt. Since we have done shape-shifting, some people are ready for this. I'm not assuming everyone is ready for it.
What would it look like if you set up what did you say? Not like you set up another group room for us to work together in? Can you explain that a little bit more?
Sure, they're called the breakout rooms. I don't have them set up in Zoom right now, because for what we're doing, they're not very useful. But right now, all of us in the Zoom meeting can see each other. So the host has the ability to split the party up into different little groups. And so I could say that, you know, Chrissy and Spring and Debbie and Crystal, you're one set of four, and you for now only see each other. And then you get to click a button and come back to this main room when you want, or I could click a button and all the main rooms disappear and we're all back together. As the host, I would be able to move between the breakout rooms to check in on people, but I only have the ability to see one at a time, which makes it not very useful for me monitoring group work.
So we've used them in one of my other classes, and the one thing I really don't like about them is that you can't ask the instructor any questions unless they're actually in the room at the time. Like you can
Right.
chat with each other through the regular chat and you see each other. But like I said, there at least the teacher I can't figure it out, but like there's no option to like if you're in the middle of the discussion with the other people in your group and you need to ask the instructor something, you have to basically sit around and wait for them to check in on the room to be able to get that to happen.
Yes, which is why I don't use them, because you need to be able to ask me questions whenever you want.
Yeah, exactly. That's the thing I don't personally like about the breakout room. So I mean, I'd be willing to try one, but be just kind of weird because, like I said,
Even
there
if we
might be
did, it's
times
just
where we're
hard for you
confused
to
on
share
something
with
and are
other.
just waiting around, not doing anything.
Right. Yeah, but even if you did, I'm not sure how you would really work together, since you don't have this fun little thing to write on with a pen.
No, yeah.
It's just kind of tricky to do math together. Um, maybe it's not. Maybe you're all so good at using your mouse that you could draw on the whiteboard. What we did with Math 25, let me show you that. I'm going to steal the screen again. So by the way, I fixed it so it's not all italics anymore. So what we did with Math 25 was use this page. Oops, no, wrong one. This one. So we had a test, and I just, before class started, put one problem on each page. And then as the class went by, this was just our standard test, our standard class session yesterday, then students would one at a time volunteer, oh, I can do that one. And this one student wrote it out on paper and emailed me the picture, and I stuck it on the board for her. Most of the students tried to write on the board with their mouse, and it's not too bad. You know, you can read this person's handwriting. And everyone just sort of took turns contributing, and I would add some comments here and there. So that seemed to work okay. Just sort of make it a, you know, start at the beginning and keep going, and everyone chimes in when they can. So we could do that kind of thing. I also gave them a copy of the test page, which was nothing special again. It's just when you go here and say, give me a test. But by having this PDF copy, it's not random. So we're all looking at the same one. So that they could say, ah, okay, I'm not really wanting to do number 1, but number 5 looks interesting. I'm going to sort of do that and get ready for it. So by the time we get to number 5, then I can chime in and say, I got it, let me do number 5. So that was a very useful thing to do. They liked that as a review day. The only difficulty with that is it's not like any one person could get a star saying that they did 70% of it. They would have to do a take-home version also to actually say, ah, give me that star, please. Does that seem like something worth doing either next class or the one after, just to put a bunch of problems on the board before we start, and then people share what they're doing?
That sounds like the simplest solution.
Do do people feel like doing review of shape-shifting in that way would be helpful? Or is the fact that your homework grades are overall as a class pretty good means that this is a waste of time if we were to do this?
I don't think it'd be a waste of time. I think that it might be essential for some members of the class, including myself. And I, however, don't have a mouse. I just use my pad. Can I write just by using that without an actual?
But
Okay.
I've tried it and it's pretty miserable. So we will all know that your handwriting is limited by your technology and not make fun of you, but that's
Okay.
we'll just pretend that a preschooler is there using your thing and that's the handwriting, because that's
Okay.
about as well as you can do with those little trackpads.
Okay. Yeah, I think probably for the good of the group, that would probably be the best to
Okay.
do.
I agree. I like the idea of doing it together as a class. I do like the PDF having been sent, though also if we're using those same questions, that way if I figured out the first two, I could look down to one of the others and go, oh, hey, I bet you I could do this one, and then chime in to be able to do it.
Okay, should we do both? Should I print out one particular copy of the shape-shifting topic midterm so that you will all have the same problems, and then send it out after class? And if you want to be extra prepared for Monday, then you could do a few problems so that when we get to them, you can say, haha, my turn to show off. And if you wanted to go for that star of I've tried this and got 70% correct, then actually sit down over the weekend or Thursday, Friday and pretend to take it as a test and send me your photographs of your papers.
I would like a copy.
Yeah, I think that'd be perfect.
Okay, so let's do that. It could be something that you try and treat as an entire midterm. It could be something you do just to get ready to show off on Monday, or you could just ignore it because other things are happening in your life. And then you won't be extra prepared for Monday, but it will still be that you can do a problem if you want.
That would help me a lot to prepare to practice.
Okay. And again, I will send the link to the page that randomly generates them. So the wrong thing to do is feeling uncomfortable and uncertain with the math and try and do 28 problems all at once. So if you want to practice, like we talked about before, just do a few at a time, get good at those, randomly get many copies of problem 1 until you're good at problem 1, get lots of versions of number 2 till you're good at number 2, and so on. And don't try and put a bunch together until you're feeling good about lots of them. So just because I send out something with 28 problems on it, that doesn't mean I'm expecting people to start there. That's sort of the end of this, right? Make sense? Okay.
I have a question about the achievement things itself.
Sure.
So I was looking.
So everyone can see what your question is better. Okay, but keep talking.
So I was looking at the So I mean, I guess I'm not really too familiar. So I'm looking at, let's just pretend like I'm looking at like the time management one, right? Or whatever one I'm looking at. Like, I guess I thought that I could like just hover and click on the little picture, the icon there, and then it would, so what is it that am I supposed to click on the little underlined things? Do those have hyperlinks or?
The underlined ones are links.
Okay. And that's how I would get into do whatever I needed to do to earn that star.
Usually, yeah.
Okay, but what about the ones that don't have those?
That's because there's not one thing to do. So since we have 3 different topic tests for shape-shifting and mad science and justice, then I can't really put one link right here for do well on a midterm because you have 3 topics. So maybe, right now your life is busy. You're not going to try the shape-shifting one at home this weekend, but a couple of weeks from now when we're finishing mad science, then you say, oh, okay, I have 3 hours. I'm going to try this. So since I don't know which one or more than one you're attempting, I can't really put one link here.
And I don't remember I don't think I was taking a test or time management. I don't know which one I was trying to look at, but
For the homeworks, they have two links. There's one link with a slightly different font for the actual turn-in pages. Right, looks familiar.
Uh,
And then the other link is for the topic. So, rounding looks differently familiar.
uh-huh.
So that's why there's two links for each of the homeworks.
And does the star automatically just appear after you complete that little session, or?
Let's pretend my code name, I'm going back to the very top. Let's pretend my code name is Cano Sub-Zero, whoever that person is. Then I hit go, and you can't see it because they're not on the screen right now, but because I clicked go, all the stars have now changed. So whatever this person has done is now checked off.
Oh, okay. So we actually have to go and do that and click go in order for them to show up.
Yes, whatever your
Okay.
name is, maybe
Okay.
it says bubblegum, you have to pick that and hit go, and then you can see, okay, I've done those two things.
Okay. All right. Thank you.
These table of contents links work after you hit go. So I am going to just pick someone else randomly, hit go. So I can click on homework after I've picked go, and it still takes me to the right spot.
And you automatically put those stars in?
If you have gotten an email back from me saying, good job, you're done with the homework, then I put the stars in.
But the other things, we are to let you know that we've done something?
Right. So if there's no star checked off and it should be checked off, then let me know. So as an easy example, if you have worked with someone to fix a homework problem, then let me know and I'll put the star here. Maybe you've been to a study session and I've seen you do it, but you still need to remind me to put the star there. Or maybe it wasn't. Maybe two of you called each other on the phone and did some homework together, and I have no idea it happened because I wasn't on the phone call. Then just still tell me, yeah, we worked together, give us these stars. You don't have to send me documented proof and videos and notarized papers and things. Just tell me that you got them done.
This day and age, it's a little difficult to get a notary.
A bunch of you have done a problem on the board, and if you haven't yet, then lots of people will when we do this thing on Monday. So that's when we'll get, and so on.
So for one of the achievements, if I show my son how to do a math problem, does that count?
Yes, there's one of them. This one here is about a classmate in particular, but there is one of them that is to, where is it? Teach someone about our math topics and teach someone about a non-class math topic. So that could certainly be someone in your family.
Okay, thank you.
You're welcome.
So the non-class math topic, would you count helping your kid with their homework for that?
Sure.
Sweet, awesome.
These aren't supposed to be hard. These are supposed to be that it is probably true in your own math histories that most of real world math was just not part of what happened in the classroom. And that's not how it should be. A math class should be a place where we can acknowledge all the math that happens in our lives and sort of go, yay, this is, we're using math. So I am trying to put in things that are easy and you're probably doing anyway, because it's still important in a math class to say, yes, there is math in real life. Okay, any other questions? These are all good questions about this.
So for the feedback ones, for the topics, where are the highlight videos it talks about?
Okay, so if you go up here, then the feedbacks. Do I still mention highlight video or do I took that out? Okay, I was going to make a highlight video for each of the subtopics like rounding and fraction format and so on, but I never did because I did other stuff. So I should change this. Okay, I'm gonna copy this then to our Jamboard just as a reminder for me. Good question, Spring. This was because there was different stages of planning here. Okay, anyway, where are we now? What I'm trying to do is after you finish, say, rounding, then sort of process it a little bit. And if I can't figure out a good way to make that work, then I'll just do something else. It was just supposed to be a short reflection of, you're done with rounding. What did you learn in rounding? That kind of thing. So don't pay too much attention to this. I will try and change it and make it something better. If you have good ideas about what types of things I can ask people to do to process a subtopic like rounding or fraction format, let me know. But the idea was that in the achievements, then you would say, okay, so 6 times after I'd finished some topic, or subtopic, then I actually thought about it a little.
Okay, thank you.
You're welcome. Thank you for pointing out that I have work to do.
Can we still get credit for homework turned in late? I've had a super hard time figuring out the website and how everything works, so I haven't been able to really get anything in, and
Yes.
I want to get hammered.
Let me emphasize that. These check marks for homework stars, there's no time limit to getting the things checked off. So if you weren't able to get the reflections done this past week, or if you haven't even done rounding yet because of website or home or whatever issues, still turn it in. You will still get all these check marks. There's no time limit for when you get things checked off here.
Okay, thank you. I was starting to freak out a little bit.
Yeah. Okay, so that's part 1. There's no due date for this part here. The place that the time limit matters is right at the very top. Normally, a plus or a minus just doesn't mean anything, right? Your next math teacher, the person you're doing a letter of recommendation for a job with, they have no idea if you got a B plus or a B minus in Math 20, what that would mean. So we're using it a little more intentionally to say that, are you engaged with the class a lot? Are you trying hard? Are you putting in effort? So if you do more stars than are needed for your letter grade, then you get the plus after your letter grade, whatever the letter grade would be. And if you have 4 late homeworks but don't get the plus, then you get the minus. So you can turn in 3 homeworks late without any penalty at all. Just don't turn in a 4th one late, or you'll get a minus on your grade unless you get a plus.
When we turn in the reflection, do we put our little code name with it or just email it?
It is up to you. Whenever you send me any homework or any assignment, including the reflections, then I have a spreadsheet that you don't see that has your names and code names, and I have to look up who is who because I don't have all your code names memorized.
Okay.
So if you put your code name in your email, then that saves me a few seconds so I don't have to get my paper and look up who you are.
Okay, perfect.
On the other hand, if you like it being more friendly and that you are not an impersonal code name or L number or something, then I am happy to look up your code name. If you just want me to say, here we go, this is me and Jazz corresponding and not her code name of whatever, Unicorn Lover 34, that's not really her. Then yeah, if you don't want to be thinking about your code name, you don't have to be thinking about your code name.
Okay.
So. But if you do put it in, it saves me a few seconds. So. All good questions. Anything else? Okay, well, let's do more questions on homework. We started with Debbie having that one about SI unit scoots. Do people have other homework questions they want to do? ready? Okay, then I will believe you for now, and we'll go on. So we were in Mad Science talking about fractions, and since some people weren't here Monday, I'm just going to do a quick review, pretending that we haven't done any of this yet, but go faster. I tried to use these pictures, and my brain got all foggy and confused. So let me see if I can do a better job of that for the people who like pictures. If you are not a picture person, then don't worry about it. Okay, so what we are doing first is fraction multiplication. If I have 1/3,
Good. We just had like a Q&A session because everybody's kind of like lost, and I was like, look, dude, I'm so fucking lost on this shit. I'm so lost, like I can't be found. I don't understand like the website. And so he kind of walked me through a little bit of it, and he's like, look, dude, don't worry. He's like, just do the homework and turn it in.
Sounds on, Justin.
Justin, yeah, do you want me to
sorry.
mute you for you?
Sorry.
That's okay.
Very funny.
Okay, so if I have 1/3, actually, let me write it in blue, be consistent. And I want to say what's half of it, then I can draw another line. And I'm going to just take half. I could either take the top half or the bottom half. Oops, that's not a small thing. And somewhere these overlap. There's an overlap between the third that I started with and the half that I decided to shine a spotlight on. So how much was the overlap? Well, there's 6 different little pieces now. So one of those 6 is the overlap. I want to do another one where the numerators are both not 1, because this is a little bit of not quite what I want. Everyone okay with my simpler picture though?
Yeah.
Okay. If you're normally a pictorial person and this isn't helping, let me know. If pictures aren't your thing, then just be patient. We'll get to the other parts of math in a moment. Okay, so in this case, I have 3/4. I'm trying to pick fractions that don't just have 1s in the numerators. And on the other direction, I'm going to do 2/3. So where is the overlap this time? It's that section. So what am I actually counting? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have twelfths. And how many do I actually have that I care about? 1, 2, 3, 4, 5, 6. Okay, so far so good. Why we're doing this is we know this rule that we multiply fractions by going across the top separately, 3 times 2 is 6, and the bottom separately, 4 times 3 is 12. So why does that work? And it's nice to be able to do it, but if you're a good, well-educated person, that shouldn't just be merely something you memorize. You should hopefully have some understanding of why that works. So looking at this picture, then, why is the denominator 4 times 3 is 12? Because I have 4 columns and 3 rows, and that makes 12 boxes. Why is the numerator 3 times 2 is 6? Because in each of the 3 rows, I have in each of the 3 columns, I'm saying things wrong, which isn't helping. Each of the 3 columns, I have 2 of the rows, and that makes 6.
Wouldn't you reduce that to 1/3?
I would, yes. If I was actually writing this and getting credit for it, then I would need to do divided by 6 top and bottom and get 1/2. But that part I'm not as interested in right now. I just want people to not only be able to do this part because they memorized it, but also to maybe see why it's working. The total pieces forms one big rectangular grid of 4 times 3. And the numerators is the smaller grid of 3 times 2. Okay, if that helped you, great. If not, that's fine. You never have to draw pictures. Let's actually move on to doing problems now that we've seen why it works. So algorithm just means process. The fraction multiplication process was multiply across the top, multiply across the bottom. Those are separate things. Let's grab one from homework. We're in mad science now for the homework. So, oh, we don't have a multiplying one, we just have a division one. Okay, then I'm going to put that over here and go back. Let's talk about division then. Division, we flip the second one and multiply. To divide fractions, flip the second one and multiply. Why are we doing that? Let's talk about that. Again, let's get our concepts done before we just practice things. So, let's look at this one actually. Way back, was it the first day of class maybe, we talked about how you can think about division as making piles of a fixed size. If I have one cake, and I'm starting not even with my whole cake, but just with half the cake, and I want to make piles of size 1/4, well, I could divide my cake into quarters. How many piles of size 1/4 do I have? I could take this piece and I can take this piece, and they are each 1/4, so this is going to equal 2. I actually had some physical papers I shredded in front of the webcam. Does that ring a bell? So now we're going to say, how does the process of writing it on the paper work, not just thinking about it or shredding papers or drawing a silly picture. So if I have 1/2, why am I flipping and multiplying? It's that every time I had one object, my black outline here, I am now wanting to have 4 objects. If I had a whole piece of paper, I could have ripped it into 4 pieces, not just 2. So this is flipping over, because the smaller I cut things into pieces, the more pieces I get per whole before I tear them into bits. I'm writing more steps than you need to, by the way. Okay, if that's good for you, great. If not, kind of meditate on it over the weekend. But the flipping and multiplying should be something that makes sense to you, not just one more rule to follow. Let's do this here again and not have any pictures, because some people are sick of that. So how do I divide by a fraction? I change it to multiplying. I flip it over. 5 times 8 is 40. 15 times 4, well, 2 15s is 30. So 4 15s would be 60. We can reduce. And get 2/3. So that was sort of our conceptual background. Maybe that was helpful to you, maybe it wasn't. As long as you can do the arithmetic, good enough. But it's nice to really understand things. This page had some big numbers on it. Do I really need to have a 60 on the page? So in this case, we only reduced at the end. We did all our multiplying first. We could take the same problem and cancel. So I could have my 8/15 and my 5/4 and say, here I can do a divided by 4, top and bottom. And we never actually write little divided by 4s floating around there. We just know in our head that we're dividing by 4. 8 divided by 4 is 2. 4 divided by 4 is 1. So far, by the way, I've done a divided by 4, so I'm going to write that here. We could also divide top and bottom by 5. And again, I'm thinking divided by 5 here and here, but I'm not actually writing it in those places.
Can't you cancel both sides? So 1 for 5 and 3 for 15?
Yeah, this 5 divided by 5 is 1. 15 divided by 5 is 3. So we've done another divided by 5. Now when I multiply across, 2 times 1 is 2. 3 times 1 is 3. And I don't have a 60 anywhere on the board on the bottom half. My math was exactly the same. Dividing by 20 and dividing by 4 and 5 are the same. I could have taken this and first divided by 4 and then divided by 5 and reduced it with 2 steps. I can't escape that I have to do this much math. But I can avoid having the big numbers on the board. So that's why people like canceling, because I never have to have a 60 show up anywhere. The lesson from this, that canceling is simply reducing early, is that anytime you have one number on top and one number on bottom, and you're multiplying fractions, you can cancel. It just so happened that these made like a diagonal pattern, but that's not important. We could cancel in one of the same parts of the same fraction also. So let's look for one. Can I get one like that randomly? Sure. So how do I divide fractions? I flip the second fraction and multiply. And if I wanted to, I can say, let's cancel here, dividing top and bottom by 2. 10 divided by 2 is 5. 18 divided by 2 is 9. I don't have to make any sort of X shape. All that I'm saying is eventually, if I did multiply across, there would be a factor of 2 in the top and the bottom. So we might as well get rid of it early. Currently, I have a 5 here and here. So let's do that. We'll divide by 5. 5 divided by 5 is 1. 5 divided by 5 is 1. There is no need to pick a camp. This isn't like some sort of political election where you have to commit yourself to being in the reducing camp or the canceling camp. So let's imagine we have this bit right here. So we can do this in 2 different ways. Maybe that's really all the reducing you wanted to do. The numbers are pretty small now. I could multiply 1 times 6 is 6. I could multiply 9 times 1 is 9. I'm not quite done. I should do a divided by 3, top and bottom. And I get 2/3 and I'm happy. Or maybe you are a canceling fanatic and you say, oh, here we'll do a divided by 3 also. 6 divided by 3 is 2. 9 divided by 3 is 3. Now when I multiply across, 1 times 2 is 2. 3 times 1 is 3. I don't have any reducing because I've done all of it as canceling. I had to do some divided by 3, but it doesn't really matter where I do it. So the point of this slide is that there's no inherent virtue to doing reducing or doing canceling. It's all the same work. It's just whatever works best for you. And most people will sort of do a little bit of canceling, do the multiplying, and then maybe do some reducing because they didn't quite do all the possible canceling. That's okay. If you miss some, you'll just get it here. Okay, questions about all of that? That was a lot of talking. No questions. Okay. Then you need to show me you're paying attention. Let's have you do one. Okay, try this yourself. I will do it in a moment after you've tried it.
Got it.
Okay. If you want to show off, you could always put it in the chat window. Then we know you got it before me, or you could just be patient. Okay, so I've written it with the flip and multiply trick or process. Someone shout out, what's the first thing they did if they did canceling?
First thing I did was flip it and then put it into multiplication. And then I crossed out the 5, put a 1, crossed out the 25 and put a 5.
Okay, I'm going to keep track over here of what we have done with canceling. That's not normally what I would write, but for this particular bit of lecturing, I am. Okay,
And
so
then,
Crystal did a canceling there of divided by 5 top and bottom.
and then the 4, I also canceled out the 4. Put a 1 on the 4, and a 16 is 4.
4 divided by 4 is 1. 16 divided by 4 is 4. Multiply across. 4 times 1 is 4. 5 times 1 is 5. And I see in chat window lots of 4/5. So, yay. Does it matter which order I cancel?
No.
No, that's fine. When I write canceling, then I try to make my slashes different. One will go this diagonal, one will go that diagonal, or maybe there's a double slash or something like that. And that is just so that at the end of the work, when I am looking over my test, I can say, what was I doing? Oh yeah, these two go together. And these two go together. And of course, right now I have fancy colors and it's easy to see this. But if I'm writing with pencil, that's why I have the habit of making my slash pairs distinct so that when I check my work, I can see. Or if I had written this nicely in my notes and now it's week 10 and I'm studying for the final, then this will be more helpful to me because I can see what I was doing weeks and weeks ago. Oh yes, these two went together. And oh yes, those two went together. So no one is going to mark you wrong if your slash marks are all exactly the same. But if you don't have any habit yet, you might as well get in the good habit of pairing up your slash marks so you can see what you've done. Okay, so that was our review of fraction multiplication. And we don't need common denominators. The point of this picture was we're just making rectangles. We have one rectangle that is the big box of 4 times 3. That's the denominators. And we had one rectangle of the smaller box that was 3 times 2. That's the numerators. And all we're doing is drawing boxes. The fact that these boxes are 12ths, I've finished drawing the boxes before I bothered to count them. To make the boxes, I don't need to know they're 12ths. That's just sort of after the fact. Fraction addition is completely different. So the point of this one was if I have 1/2, oops, let me take off the weird pen. If I have 1/2 and 1/4, and I'm trying to put them together, with addition, then I can take the 1/2 and say, let's not call it 1/2. Let's say that it's also 2/4, because it is. And I can count how many quarters I have. I have 1, 2, 3 of my quarters. But during that process, before I added, I was really paying attention to the fact that I had quarters. Unlike multiplying, where I can ignore the fact it's 12ths until I am done drawing my picture, until the process is done. So this is probably going over your head a little bit, but think about it more, and you can see that we need common denominators for adding because the denominator is part of the actual adding. We don't need common denominators when we multiply because it's only about writing the answer after we multiply. And eventually that can make sense too. But anyway, for fraction addition, we need common denominators. When we're trying to get common denominators, we had 3 different situations. And I put them on different slides last time. I'm going to combine them to one slide this time. Okay, so our first example has a denominator that's a multiple of the other. So we're going to take a 12th and a 6th. Whenever I write fraction addition, I want to leave some space to the right of the fractions. So if I need to do some unreducing, I can. In this case, 12 is great. It doesn't need to change at all. I can take my 6 and make it a 12. I'm allowed to multiply the top and bottom of a fraction by whatever I want. And if I pick 2, 6 times 2 is 12. If I do something to one part of a fraction, I have to do the same thing to the other part to be fair. We've already talked in the shape-shifting about unreducing fractions. So now I have 1/12 plus 2/12, and I get 3/12. I'm not quite done. I do need to say, by the way, let's reduce this. But for the addition part, I only had to play with one denominator because the other one was a target for the one I'm changing. Does that column make sense to everybody? Holler if I need to do another example of that kind. Okay, everyone's quiet. You're either asleep or it's okay. If there's no common factors, I'll do a different one than we did last time. Then this trick won't work. I can't say one denominator is a target for how to adjust the other one. I can't make the 5 a 4. I can't take the 4 and turn it into a 5. And there's nothing they have in common as a shared factor. It's not like they're both even or they're both multiples of 3. So my only choice is what I'll call the brute force method. Where I'm going to take each denominator and multiply it by the other. And just like before, if I do something to the bottom, to be fair, I have to do something to the top. And this will always make the denominators the same because it doesn't matter the order I multiply things. 4 times 5 is 5 times 4. I might know it is 20, but even if I don't know it's 20, I know that they are the same because they are two numbers being multiplied together. Everyone okay with my middle column here?
Yeah.
The last possibility is where the denominators have some things in common. It's not the first column. I can't take the 8 and make it a 10, or I can't take the 10 and make it an 8. Neither number is a good target for the other, so it's not that. It's also true, however, that I don't have to do all the work of brute forcing it. I could, so don't draw what I'm drawing, but it is still true that if I wanted to, I could multiply each by the other, just like in the middle. And if this is how you like doing it, you can do it this way. If I was to keep going, however, you'd see that the numbers get kind of big. I have 10 eightieths. I have 8 eightieths. So I have 18 eightieths. And I'll reduce that. Oops, not by 8. So maybe there's a better way to do it than the brute force method of multiplying each number by the other. Let's see what that would be. First, I'm going to steal this though, so that the people that do like the brute force method can have their own private copy of this slide. Okay, but what can we do that's better? Oh, it's not letting me undo. Okay, fine, I will undo and then I will paste. Ah, I have tricked it. Okay. So the better method is to say that there is a 2 in common. The 8 is 2 times 4. And the 10 is 2 times 5. If you were here Monday, this is the same method I explained, but with a different word and different picture, because sometimes it helps to have it explained more than once. So if you liked it the old way from Monday, great. This is actually the same thing, even if it looks different. So I've taken it and I made a factor tree. Now these factor trees aren't complete. I could take the 4 and keep going, but I don't care. All I have is what's in common and what's not shared. If you are good at factorization, then splitting it up into what's the same in both numbers and what's not the same is pretty quick. If you're not good at factorization, then the brute force method is probably just as fast as this trick. Then what I have to do next is say all I care about is the not shared numbers. So instead of putting the whole 10 here and 8 here, we're only going to put the not shared numbers. So we get the 5 here, because that's the not shared from the other fraction. And we get the 4 here, because that's the not shared from the other fraction. Okay, that was a lot of flipping around. Can I say it again? I make a partial factor tree, what they have in common and what they don't, and I multiply each one by the what they don't of the other fraction. So then I have 5/40ths plus 4/40ths is 9/40ths, and I am done without any 80ths on the board.
When do you use the because I have like a process of common denominators using a factor tree. Then you cross out the second pair, and then you multiply the pairs that are in common. Or no, you multiply the remaining. Is it the remaining? Oh no, I see. Okay, I get it. Never mind. I got
Okay.
confused in my notes.
Yeah,
Okay.
that's fine. I explained it a little
Yeah.
differently last
Yeah.
time.
Okay. Well, when I read it out loud, it clicked. What? Yeah. Okay. Okay.
So,
It's not like multiplying. It's not like I go 2 times 4 times 5 and get an answer,
no,
which is what I did on one of the problems that we did last week.
do you want me to do it in the Monday style also, just for coherency?
Yes, please.
Yes, please. Okay, so I'm going to make a new slide for 1/8 plus 1/10. What I talked about on Monday was sometimes this trick doesn't work for people because they're not very good at seeing what's in common and what's not. This really is assuming you can just look at 10 and 8 and make this two-part factor tree. But if that's not an easy thing for you to do, can we make a longer process that does that for you? Everyone see where I'm going? It would be nice if I could make just a tiny factor tree, but what if I can't? Then that's okay. I will make a longer factor tree. Which color is what? That one's green. Okay. So I will take 8 and I will make a complete factor tree because I am pretending that I am not good at seeing what 8 and 10 have in common. And we can do another example after this with numbers that are less obvious what they have in common. And here I have a 2 and a 5. So I have just gone till it stops, right? Prime numbers, I can't do any more factor trees. Same kind of factor tree we did when we were looking at prime factorization back in the first week of class. Then the next step of the process is anytime there's something in common, I'm going to circle it on both and cross out the second copy. And then my third step is anything left over, I'm going to circle and not cross out. So let me write out these steps. So 1, make a complete factor tree. 2, that the primes in common circled 1 on each of the trees, but cross out the second. And then 3, everything left, just circle. Then finally, multiply all the circles not crossed out. So what is that? A 2 times a 2 times a 2 times a 5, and I get to 40. So that's telling me that 40 is my common denominator. And it's actually what's called the least common denominator. It's the smallest one that would work, because 80 would work too. Does that match your notes for Monday better, Chrissy?
Yes, but actually, and so for me, like what you showed us today, though, like it kind of makes more sense because I guess maybe it's simpler. You don't have to go all the way through all those steps, and then it's really clear to me in my mind, like I have to do that to both sides. So like on the 1/8, you know, on the 1/8 part, I have to bring the 5 from the other side over and multiply it on both sides, like the top and the bottom, the numerator and the denominator. So it's pretty clear there. Like, yeah, I like the way you did it today. I just got confused for a second until I read it out loud, and then it clicked. What? Yeah.
Okay,
Thank you.
so no problem. Okay, so we had 3 different categories, situations for how denominators might be. One is a target of the other, no choice but brute force, or if we're clever, we can do something with less work than brute force. There were also 3 methods for the least common denominator. And the first one, so the first one is factor trees. On the next slide, the second one is ignore it. Because as I mentioned before, it always works to multiply each denominator by the other. Is 80 the least common denominator? No, 40 is. But 80 works. So if this is fast and easy and reliable, some people just always brute force. The third method was listing all the multiples. I can just say, I have an 8 and a 10. So 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, 8 times 5 is 40, 8 times 6 is 48, and so on. 10 times 2 is 20, 30, 40, aha! I have something in common. And that's the first time they were in common. So it's a lot to juggle in your mind, which is one reason people don't like adding fractions. You have 3 situations, and if you're trying to find a common multiple, you have 3 different methods. You can do something fancy. I am not counting the one that's just sort of look at it and know what to do as a method. This is sort of like method 4. Maybe I should write that. go away, Zoom thing. Okay, so that fourth method was notice what they have in common and just multiply each one by the other. So the good news is you don't have to master all of this. So pick what method works best for you and practice that one, and feel free to ignore the others. Right? Most people will never make a list of multiples when they're taking a math test. For almost everyone, this is a big, slow project, even though the calculator can do all the work for you. So if you like it, great. If not, pick one of the other methods. Just make sure you can do something. More example problems. We've done that one a lot. Oh, okay. Let's do that. Okay, I'm going to put 2 problems up. So work on those, show off in chat if you get done early, and after a moment I will start them.
Did we go over subtract?
Do we go over subtraction? I don't know if we have.
I don't think we did.
Okay, figure it out.
Okay.
Yeah, I don't think we did either.
Fine, I just
I have
didn't
any of
remember
it
if
in
we
my
did.
notes.
You're
Isn't
smart.
subtracting supposed to be the easiest of them?
Is which one?
Subtracting, isn't that the easiest of them all?
No, multiplying is, because you don't need any common denominators. And there's no
Okay.
flip. That's why we do multiplying first, because it's the easiest. I'm going to at least write them a little better, because you should always write your fractions with one number on top of the other. Unfortunately, when typing them, we have to make it kind of diagonal, but hopefully all of your scratch papers always have fractions written nicely with one number on top of the other. Does someone want to shout out how they did 27? It could be the person who typed or someone else.
So for the first one, I multiplied 3/4 by 3 and got
Oh.
9/12 to get the common denominator. And then I subtracted the 1/12 and got 8/12 and had to reduce that by dividing by 4 and got 2/3.
By the way, are all of my multiplication symbols clear, that there's little dots, and on your screen you can see that it's not subtraction, because that has been an issue before.
Yeah.
Okay, holler if it ever looks like I'm subtracting instead of dividing. Okay, so this was case 1, that one denominator is a multiple of the other, one denominator can serve as a target for the other, we can just take the 4 and make it a 12. We don't have to do anything with the 1/12. For subtracting, then yes, you're smart, you can handle it. 9 minus 1 is 8. Instead of adding the tops, you subtract the tops, but you can do that. Okay, someone holler out for 29. What do we do?
Don't we just add the two top numbers?
We can't because the denominators don't match yet.
Oh, okay.
So,
So you find a common denominator, which would be 60.
okay, and how did you get the 60? We just had 4 different ways to find the 60. Did you use one of my 4 ways? Or
Yeah, I did number 3.
to list the multiples. Okay, so she just said that we have 12, 24, 36, 48, 60, and I'm out of room. Hopefully we'll get a common one before I run out of room. Aha, we did. We got a common one. So 60 is going to work. Actually, I'm going to erase this. Can I put it back, by the way? I can. Okay. I'm going to get rid of all that nice work. Make a copy. And then put back all that nice work. Because somebody is going to say, I don't like the listing multiple ways. Let me do it my way. So now they can. Okay, but continuing that. So we have 60s. Now here's a cute little trick. So this is 12 times 1, 12 times 2, 12 times 3, 12 times 4, 12 times 5. So this is a times 5 to get to 60. On the bottom, 15 times 1, 15 times 2, 15 times 3, 15 times 4. So this is a times 4 to get from 15 to 60. So 5 and 8 is 13. Any reducing? No, people are shaking their head. Okay. Questions about either of these, except for the question of I want to do 29 a different way, because we'll get to that in a moment.
So it's because 13 is a prime number, you can't reduce it,
Right.
right? Okay.
That's a big clue. I'm just done. No questions? Okay, who did 29 a different way without listing the multiples? So actually, let's go back here. So we had 3 other ways to do least common denominators. You could ignore it. You could make a complete factor tree, or you could make the ultra efficient tiny factor tree. Which one should we do for this next?
The factor tree.
The whole factor tree?
No, just the little one.
The little one. What do they have in common?
The 3 and 4 and 3 and 5.
They have the 3 in common. Whoops, make my... So the 3 in common, I don't care about. Instead, I'm just going to say that the 4 from this factor tree needs to go over here. And the 5 from this factor tree needs to go over here. So then I wind up with 5/60 plus 8/60 is my 13/60. Everyone happy with that version of 29? Okay, we're still leaving out some people. If anyone is doing it the brute force method and feeling marginalized, I can do that. If anyone's doing the complete factor tree method and feeling left out, I can do that. Should I do another 29?
Yeah, I did the brute force method and came up with a different answer.
Okay, so let's look at that. So maybe you're saying least common denominators are for wimps. I'm not afraid of big numbers. I'm just going to multiply each fraction by the other's denominator because that always works. Okay, so 15 times 12 is 180. 24 and 15 is going to be 39 over 180. Now I'm going to need to reduce. $13, 39 divided by 3 will be 13. 180 divided by 3 will be 60. And I'm done. Did that help you?
Yeah, I know exactly what I did.
Okay. Okay, so your job is to practice a lot, figure out which method you like best. Let me label them before we leave these slides. So this was the brute force. This was the ultra efficient. And this was the list of multiples. The fact that no one picked the complete factor trees isn't uncommon. This is kind of the least popular way of doing things. So I'm not going to bother to write that one on. But do enough problems that you figure out which of the 3 popular methods you like best and get good at one of them.
Is there any time where one of those methods would actually be better than another one, or is it all specifically in what you prefer doing?
There is this category. If there is nothing in common, then I have to brute force. If I try and be clever, I'm not going to find anything that 4 and 5 shares. So all 3 methods, right? If you list multiples and there's nothing in common, then you would list each multiple as many times as the other number. If there's nothing in common and you try and be ultra efficient, you're not going to find any number bigger than 1 on both factor trees. So the other methods sometimes turn into brute force because they have no choice. Good question. On the homework, we have a decimal one here. Let's do this. Can I get one without some? Oops, no, that's not what I want. I want over here. There we go. Okay. Well, this doesn't look as friendly. So 18 over 190. Multiply by flipping, or divide by flipping and multiplying. Now we had this trick from earlier where if I have a fraction with a decimal in it, I can do the same number of scoots on top and bottom. I can do that, or I cannot do that. It's up to you. I certainly, when looking at this, will say, you know, I think it would make things nicer to cancel. But at this point, I am ready to multiply. Fit that in there. Again, if I shrink. Okay. Oh, terrible line. There we go. So I can just say 18 times 1 is 18. What's 10 times 0.3?
1.3.
No, that would be
3.
Yeah, times 10 is just one decimal scoot to the right. So 10 times 0.3 is just 3. Oh, and I have a little bit of reducing to do. So I don't need to get rid of the 0.3 as a 0.3. I can just multiply across. I have a calculator. Multiplying things with decimals isn't a big deal. If you wanted to, you could. If it really makes you uncomfortable, then I can scoot there, and I can scoot there. And I can multiply 80 times 10, or 18 times 10 on the top, and 10 times 3 on the bottom. Maybe I would cancel there, maybe I wouldn't, and reduce later, whatever. So you can do some scoots if it helps you, but you don't need to. So don't let the second problem in the random homework with the decimal worry you too much. You're just multiplying across. You can still do that with a decimal. Okay, last not least, what if we have 3 numbers? What would I do?
Find a common denominator with the bottom numbers.
Yeah, so now I need to worry about thirds and fourths and sixths. The choice of which method to use with 3 might be different. Brute force, you could multiply all 3 together. I could say that this one I do a times 4 and a times 6. This one I do a times 3 and a times 6. This one I do a times 3 and a times 4, right? That's the brute force method. Like always, it gets big, but it works. And I would do the same on the tops, right? Or you could say, I'm going to make some little ultra efficient factor trees and try and see what's in common. That gets a little complicated because it's hard to compare 3 things at once. It's easier to compare just 2 with that. I'm going to let you play with that before I try it. Or you could say, I'm just going to list some multiples that I have 3, 6, 9, 12, 15.
Well, we know that 12 goes into all 3 of those numbers.
Yes, these are small and easy, and we can see that 12 is going to work. Aha, here we go. So the list of multiples method becomes a lot more popular when you have more than 2 fractions. So that doesn't mean it's the best method. There is some personal preference to this. But if you do some homework and you decide that, you know, when I am with 2 fractions, I really like either brute force or ultra efficient. But when I'm with 3 or more, I like the list of multiples, and that is a very common personal preference. So just a heads up about that. And now we're finally done with both multiplying and dividing and adding and subtracting fractions. In your lecture note page, then there's always spots for 2 different Jamboards. And we only used 1 Jamboard today. We didn't get past 20 slides. So what I will do is make a blank Jamboard that is available for everyone to write on and put it here, but kind of here, right? The next row. And then if you just want to have something to write on to work together with each other over the weekend, there will be this completely blank set of 20 pages, and you can claim a page and use it however you want. So if that helps you, there it is. I don't have to do that. You could always make your own Jamboard and share it with people and work together. And you could even send me a link to it and say I'm turning in some work or something. But if making your own Jamboard seems a little weird, then I'm just going to make a blank one for you and put it here in the lecture notes. Anything else? We have 1 more minute.
So for the midterm test, we're supposed to work on the first few problems over the weekend.
What I would do is maybe even before you get my email, if you happen to not want to eat lunch, I'm joking, then go down in the playgrounds and start taking some shape-shifting tests yourself. I'm going to, in my after-class email, send you this direct link so you don't have to find it like I just did, but it's just in the tests in the playgrounds. And before you look at the PDF of a certain one of these that I send everyone, so we all have the same one, just practice doing some problems. And that's where I would do just 1 or 2 problems and then reload it, and do 1 or 2 and reload it, and pretend you're doing martial arts or something else. That's the right way to practice things. And once on the random ones, you're feeling comfortable, then look at the one I send out as a PDF file for everyone to have the same version. Does that make sense?
Yeah.
So use the randomness to practice things. By the way, if number 4 you hate, skip number 4. So use the randomness to practice things in whatever works for you. I don't know how much free time you'll have. And then when you're ready to show off on something, even if it's just problem 1 or problem 2, someone's going to need to do that on the board. Then look at the one I actually sent you so you can rehearse the same problems we'll talk about on Monday. And if you want, send me an email and say, I've practiced number 2. I'm ready to do it on the board. I get it. And then so when I set up the jam board for number 2, I'll make a little note that this is your problem. No one else gets to volunteer for it. Okay, I'm gonna stop the recording.